So for a question like this, you want to start off with an inner loop right here. I'll call it B. And basically it has three parts, three lines, one, two, three. And what you want to do is just put this down right here, this some notation, 3. And you go from j equal n to n plus 1. And then you can just, you can factor out the 3 and like put it outside. N plus 1, j equal n. And what you can do now is just put 3 and then do the parentheses or whatever you want to do. Then you can go n plus 1 minus n and plus 1. These two cancel out. You get 3, 2. Okay, so you get 6 for this. Oh no, my bad. You get n plus I. It's not a 1. My bad. I didn't see that. You get 1 minus n plus 1. So these cancel out. You get I plus 1. Okay, and then you put a 3 around it. You get 3 plus I. 3 plus 3I. That's your B. So now you want to go on to the bigger layer and go like over here and just. So you got 1, 2, and then you got plus these 2. Okay, so what you want to do is do the sum notation again. This is for this one down here. Then you put 2 because you have 2 over here, 2, and then you put this one down here, 2 plus 3 plus 3I. So now you're gonna have you have 5 plus 3I. Now you can just you can move them around. What you can do now is like this. You have to use the sum notation formulas for this part. You go, so you put 5 outside, and then you just put 1 here from let's see, from I equals 0 to n, and then you do plus, you get 3, and you have your I inside, from 0 to n. What you want to do now is just put the formula for this and the formula for this. For this one, it's b minus a plus 1. For this one, it's n minus 1 over 2. And that's that for that. You just got to do it now. You get 5, n minus 0. So this is 5n. You do plus. You got 3. You got n. You got n minus 1 over 2. So you get 5n plus 3. And do like this. You can just keep it like this, honestly. You don't have to do the full... You don't have to do the full thing. You just have to show that you know that you got this. Now that's your answer. You can simplify it more if you want to, but you don't need to. Now for the next one. Like limit definition, it's just, this is basically like calc 1. You just write the limit and infinity. You just got to show that it works. F over G. And now for this one, you got to determine whether limit to determine whether Fn. Oh, you got to determine whether n squared. So you grab the whole thing, n plus 1 times ln n over n squared. There's a lot of ways to go about this, but my favorite way is to do the just deriving it until like you get a constant. So you got to do product rule for these two. Then you go, so you get 1. I'm just gonna skip the steps because it's just pretty simple derivatives. 1 times, so you get 1 ln n plus n plus 1 over n. You get, so, and then you get 2n. So this cancels out on the next one. You get 1 over n over 2. Over 2, okay. And now you should get a constant after all this. Hold on, let me double check. Yeah, there isn't much after that. Um, I think I messed up somewhere, but the point is just derive it, get the constant, and that's just how you prove that it's on squared. If you get a constant after that. Hold on, let me just double check if this is true. Ln turns into 1 ln squared over 2n. You get 1 over n over 2. Yeah, it just becomes a constant if you keep deriving it, because you get 1 over 2n, and then you get 1 over 2. That's just how it is over here, and then you just get your constant. Okay, now for the next one, you got to circle all that can be true. So you can cancel one out. So you need something n3 or bigger. It can be equal or bigger than n3. So this one's gone. It's n squared. This one works. You have the n and the log together. This one definitely works because anything times n is greater than like n times any number, because this one keeps growing. So these two options both work. To find the order of the big theta here, what you got to do is just get, so this is multiplying each other. So you have 2n and n3. You just put n3 times 2n, and that's your order of the big O. I mean big theta this time. If you have two algorithms for the same task, which one is better for larger sizes, right? So the one better for larger sizes is this one, S1, due to the fact that it's just a bigger, it's bigger than the other one. It's bigger than log n. So you could just say like, oh yeah, this one is like better because it has a larger size and it just goes up faster. It increases faster, I mean. Yeah.